In this tutorial, we are going to create an automatic glass of water. Let's take a look at a small animation I made just to show you how the finished glass looks animated. As you can see, the surface remains flat in relation to the scene, imitating gravity, and the amount even decreases the more the glass is tilted. Notice how there is much less in the glass now than when it started. The liquid doesn't exactly behave physically correct since it is always completely flat, and the amount is not consistent. But it is good for simple animations since it doesn't use any simulations. It is all real time using drivers, no baking needed. So, now when you know what the final result looks like, let's take a closer look at the controls of the glass. It is this big bone that we use to control the glass in our scene. Place it, scale it, and rotate it any way you want to adjust the glass. As you can see, everything about the liquid, keeping the surface level and reducing the amount when it goes over the edge, is done automatically. You might notice that the surface sometimes lag a bit when I pose the glass, but don't fear. When you animate it, it always behaves perfectly, just as you saw in the animation in the beginning. Now, let's use Suzanne to see what it looks like when a character is drinking. I am placing the 3D cursor by the mouth so I can rotate around it. The lack of water actually leaving the glass is not a problem since we can't see inside of the character's mouth. Hiding the edge and having the amount decreased automatically is enough to sell the illusion of drinking. Let's hide Suzanne again since we won't need her anymore. Except for the glass bone, we have a floating panel with 2 controls. Having a floating panel instead of sliders in the UI allows us to place the controls exactly how we want them in the viewport. The first control that says refill is used to increase the amount of water again. Grab the arrow, slide it to the right to refill, and return it to its original position when the glass has the amount you want. Below the refill, we have a glass style control where you can choose the look of the glass. Moving the controller along the slider makes the glass switch between 3 different styles. The current simple glass, one with an ear, and one with a foot. And that's it. So, let's get started. Let's start by adding the actual liquid. Delete the default objects and add a cylinder. Move it 1 unit up so it sits on the ground plane and rename it liquid. I will give it a quick and simple light blue color just so it looks like water here in the viewport. To be able to change the shape and size of this liquid mesh, we are going to use what is called a Boolean modifier. A Boolean modifier takes 2 different meshes and gives us the difference between them. What this means is that we can use another mesh to cut away a part of our liquid, giving us a different shape and size. We will always want the surface of the liquid to be flat, so we will use a simple cube as the object for cutting. Add a cube and rename it surface bool, short for Boolean. Scale it 1.5 along C and 3 along X and Y so it can easily cover the entire liquid. Move it 3.5 units up so it sits right on top of the liquid. Now we are ready to add the Boolean modifier. Select the liquid mesh, add the modifier, select the difference as operation, and set the object to surface bool. If we now try to rotate or move the surface bool, we can't see any difference. This is because the surface bool is in the way, hiding the shape it creates. Give it a maximum draw type of wire so we can see through it. And now when we rotate or move the cube, we can clearly see that it changes the shape of the liquid. Rotating it makes the surface lean, and moving it down decreases the amount. The liquid is now working, so let's give it a glass to be in. Add another cylinder and name it glass. Move it up 1 unit so it sits on the ground floor, and scale it up just slightly so the 2 don't intersect. Remove the top surface so it looks like a real glass. Now when we move the surface object, the glass stays as it is, while the surface of the liquid changes. However, it becomes pretty hard to see exactly where the surface is now when the glass is in the way. To make this easier to work with, it would be better if we could see through parts of the glass. A way to achieve this is by activating backface culling in the shading tab. This makes the faces of our model only visible from one direction, the direction of their normals. As you can see, the backside of the glass is now transparent. However, we want the opposite. We want the front to be transparent and the back to be solid. To get this, we just need to flip the normals so they point in the opposite direction. Enter Edit Mode, select every face and flip normals. And now every face in the front becomes see-through, so we can clearly see the shape of the surface while we work. Great! We now have the glass and the liquid inside of it, so let's start working on the ability to control it. Add an armature and name it Glass Control. Set it to B-Bone Display Style and activate X-Ray so the bones are always visible. Also set the maximum draw type to wire so it doesn't cover as much of the viewport. The bone that is created by default will be our master bone, used to move the entire glass. Make it bigger by moving the tail 1 unit up so it covers the entire glass and name it Glass Master. Parent both the liquid and the glass to the bone. And now we can move the entire glass as we want by moving the bone. I want to be able to control the surface through the armature as well, so add another bone by extruding the top and rename it Surface. Parent the surface spool to it. And now rotating the extruded bone tilts the surface of the liquid. However, rotating the surface bone manually will not be necessary, since we always want the surface to be flat compared to the scene, imitating gravity. No matter how we rotate the glass, the surface should keep the same angle. This can be achieved by turning off the inherent rotation of the surface bone. Now it doesn't listen to the rotation of the master bone anymore, so the surface keeps its angle when I lean the glass. It still doesn't look realistic though, and that is because the surface doesn't remain flat. The center of the leaning is in the middle of the glass, which gives us a very weird angle, since half of the surface pool cube ends up outside of the liquid. We want the cube to affect the entire surface, making it flat. This is easy to fix by moving the surface bone to the edge. The bone is currently connected to its parent, so disconnect it before you move it 1 unit against X so it lines up with the edge. And now the water sticks to the edge, making the surface remain flat and realistic when I lean the glass. Great! Currently, I can only lean this glass in a single direction. Any other way than straight against the surface bone will not create a flat surface. For the surface pool object to always cover the entire surface, making it flat, the surface bone needs to be at the edge the glass is leaning towards. So how can this be achieved? We could try moving it around by changing its location values. Moving it to this edge allows us to rotate the glass in this direction. And moving it to this edge allows us to rotate it in this direction. This would work, but there is an easier solution, and that is to simply rotate the surface bone around the center by rotating its parent. Currently it is the master bone that is its parent, but we don't want to automatically rotate that since it is used as a control. So instead, we will add a bone between the master bone and the surface bone. That way, we can rotate the surface bone around the center while the master bone remains still. Increase the thickness of the master bone so we get some space to add more things in the center. Then add a new bone, name it Rotation, and make it as long as the master. If I now parent the rotation bone to the master, and the surface bone to the rotation bone, I can place the surface bone anywhere I want around the edge by rotating the rotation bone. We want this rotation to happen automatically depending on how the glass is leaning. The surface bone should always point in the direction of the glass. This can be done by adding a track to constraint. The track to constraint makes the bone point to something of our choice, and as a result also rotates the bone towards what it is pointing at. So, we want to add a track to constraint to the rotation bone so we can make it rotate to the right angle automatically. let's add another bone so the constraint has something to point at. Name it track and place it straight above the rotation bone. If we now add a track 2 constraint to the rotation bone and set the target to the track bone, it rotates depending on where I place the track bone. Currently the surface bone is not in the right location in relation to the rotation bone. It should point in the same direction as the track bone, but instead it is placed to the side. To fix this, we can simply move it to the other edge in edit mode. And now the surface bone always points in the same direction as the track bone. To make this angle automatic, all we need to do is to parent the track bone to the master, so it is moved when we rotate the glass. And now the liquid always has the correct angle, no matter how we lean the glass. Great! When we lean the glass like this, the amount of liquid should decrease. So when we straighten up the glass again, the surface level should be lower than it was before. This is currently not the case. When I raise the glass, the water is raised to the top just like before. So we need a way to save the amount of liquid left and then drive the height of the surface based on that amount. Let's start with just keeping track of the amount of liquid left. Instead of trying to calculate the volume in cubic centimeters or anything like that, I will simply keep track of the lowest angle the glass has had. Based on that, we can make a very quick and simple assumption of how much liquid should be left. If the lowest angle it has had is 0 degrees, the glass has not been tilted yet and everything should still be there. If the lowest angle it has had is 90 degrees, it means that it has been tilted straight to the side and no liquid should be left. And if the lowest angle is 45 degrees, right in the middle, the glass has been tilted halfway and half of the liquid should be left. So we want to check the angle of the glass and always remember the biggest angle it has had and therefore remember how much liquid is left. Add a custom property and name it liquid amount. Here we will save the amount of liquid left in the form of the biggest angle the glass has had. Add a driver to it and open the driver window. This liquid amount will be dependent on the angle of the glass, so we need to add that as a variable. We can easily get the angle of the glass no matter which way it rotates by looking at the rotation bone. Since it always points towards the direction of the glass, the x-axis of the rotation bone always gives us the angle of the glass. And name it current angle. And now we directly get a value between 0 and 90 degrees, showing us the current angle of the glass no matter what direction it is leaning. Set the expression to just use the raw current angle. The driver value becomes 1.571. This is because the rotation uses radians instead of degrees. In radians, one full rotation is 2 pi, so a quarter rotation, 90 degrees, becomes a half pi, approximately 1.571. Instead of having the rotation giving us a value between 0 and a half pi, I would rather have a value between 0 and 1, showing us how full the glass is from 0 to 100%. We can get this by dividing the current angle by a half pi. And now the driver value is 1 when the glass is straight up, and when I rotate it straight to the side, it reaches 0. Great! Now the driver tells us how much liquid there currently is. Rotating it 45 degrees gives us a driver value of 0.5. The only problem is that when I raise the glass again, the value increases. How can we make the driver stick to the lowest value it has ever had so it remembers the amount that should be left? By making it reference itself. Let me show you what I mean. Add the property itself, liquid amount, as a variable. This gives us the ability to check the previous value whenever the driver is updated. We can compare the previous amount to the current amount and pick the one that is the smallest by using a min function. Min, the current amount, comma, amount. This way we will only pick the current amount if it is smaller than the previous amount. This property can now only decrease in value, getting lower and lower, always remembering the smallest value. This works great, but what do we do when we want to start over if the property is designed to never increase in value again? We simply need to add something more to the end of the expression. If I add +1, the driver value is increased to over 1 again. And if we delete the 1, the driver starts to work like before, remembering the lowest value. Instead of manually having to add a value every time we want to reset the driver, let's create a refill property. Add a new custom property, name it refill, give it a default value of 0, and add it as a variable. If I now add it to the end of the expression, just like I did with the one before, I can increase the liquid amount by increasing the refill property. And if I return it to 0, it will be like the refill part of the expression doesn't exist, making the driver work like before. And now we always have how much is left in the glass saved as a 0 to 1 value. Let's just quickly reset the amount. Great. Now when we know how much should be left in the glass, we can use that value to visually change the amount of liquid. Moving the surface bone down decreases the amount, so we want to drive that height of the surface. Add a driver to the Y location of the surface bone and add the liquid amount as a variable. Add it in the expression as a start. This moves the surface bone 1 unit above the glass right away. We want the surface to start in its original location, right at the top, so we need to subtract 1 from it, giving the driver a value of 0 when the amount is 1. Now it stays in place when the amount is 1 and moves down when it is less. When the amount reaches 0, the lowest it can be, the surface is currently moved 1 unit down. Since the glass is 2 units high, we want it to move twice as far as it currently does, so multiply everything by 2. And now the surface moves down when the liquid amount decreases, reaching the bottom whenever the current angle reaches 90. Let's refill the glass again. Here you can notice an issue. The surface is moved far away from the glass when we drag the refill to the maximum. This is because the liquid amount gets a value of 2. But how can this happen? When we look at our properties, we can clearly see that it has a value of just 1, since the property has a limit from 0 to 1. Unfortunately, limiting the property through this edit button and setting a range is not enough to properly limit values created by a driver. So we need to limit the actual expression of the driver as well. We can do this by adding a min and max function to it, limiting it to between 0 and 1. First add a min function 1 around everything, and then a max function 0 around everything again. And now the liquid always has the proper amount, staying within 0 to 1. Now, moving on to working on the behavior of the liquid. The driving of the surface height is not something we always want. Before we added a location driver to the surface, the water stuck to the edge of the glass, like it should when the glass is leaned. But now that behavior is gone. We would like to bring it back. It is only when the glass is standing straight up, the surface should be moved down. When the glass is leaning to the side, the surface bone should not be moved at all, so the liquid stays by the edge. We can think of this as 2 states, keeping the surface by the edge or driving it down. We need to fade between these 2 states depending on how close the glass is to its maximum angle. Since the amount of liquid is decreased when we lean the glass, it is only when we lean the glass further than we have before the liquid should be by the edge. The closer the glass is to the biggest angle it has had, the closer the water should be to the edge. So let's start by figuring out just that, how close the current angle is to the biggest angle it has had. Add another property called close to maximum. Add a driver to it, and add the current angle and the liquid amount as variables. We want this one to give us a value between 0 and 1, showing how close the current angle is to the maximum angle. If the glass stands straight up, we want a value of 1 since it is as far away from the biggest angle it can be. And if the current angle is the same as the maximum angle, we want a value of 0 since they are the same. First of all, the current angle needs to be divided by a half pi, just like we did with the liquid amount, so both variables gives us a value from 0 to 1. So we start by adding that to the expression. And now the driver gets a value of 1 since the glass is standing up. We want the difference between the current angle and the maximum angle it has had, so simply take this current angle minus the amount. Remember that the liquid amount is simply the maximum angle it has had converted to a 0 to 1 value. So when we take this current angle divided by a half pi minus the amount, we get the difference between the current angle and the maximum angle. Now we have the difference. Currently it is none since the amount is 1 and the glass is standing straight. If I lean the glass to the side, the difference is still 0 since they remain the same. However, when I raise the glass again, the difference between the current and the maximum angle increases. When the glass stands straight, we have a difference of 0.291. However, since standing straight up is the furthest away we can get from the maximum angle, we would rather want the driver to get a value of 1 instead, showing that it is the biggest possible difference we can have. That way the driver value becomes more consistent. No matter how far the glass has been tilted, a value of 0 is always no difference between the current and maximum angle, and a value of 1 is always the maximum difference. So, how can we turn this 0.291 value into 1? To turn a value into 1, no matter how big or small it was before, we need to simply divide the value by itself. X divided by x equals 1. So, we need to divide everything by itself. However, we can't just copy the entire expression we already have and divide by that. Then we would always get a value of 1, making the driver completely pointless. No, what we divide by should only be the same when the glass stands straight up, since that is when we want a value of 1. So let's look at what we currently have. When the glass is straight up, this current angle part is simply 1. So when the glass is standing straight up, this expression can be written as 1 minus amount. This is what we will need to divide everything by. 1 minus amount. Now the expression only becomes divided by itself when the glass is standing up, giving us a value of 1. And now the driver gets a value of 1 when the glass stands straight up, and a value of 0 when it reaches its lowest point. We always need to avoid dividing by 0, which will happen in this case when the glass hasn't been leaned at all. An amount of 1 would give us 1 minus 1, equaling 0. To stop this from happening, add a min 0.999 function around the amount. And now it will never reach 1, resulting in a denominator of 0. We now have a property that gives us a 0 to 1 value of how close the current angle is to the maximum angle. Let's use this property to choose how much we should drive the surface. Add it to the surface location driver as a variable. When the glass is leaned the furthest it has, we want the liquid to be by the edge, so we want this driver to just have a value of 0, not doing anything. And when the glass is standing straight up, we want the full effect of this driver, giving the surface the correct height. We can get this behavior by simply multiplying everything by the close to maximum property. When it is 0, everything becomes 0 and the expression basically disappears. When it is at 1, it is multiplied by 1, giving us what we had before. And now the liquid moves towards the edge when I lean the glass, and back to the center when I straighten it up. Great. However, the surface is looking a bit laggy. This happens when we split things into multiple steps. First we have this close to maximum driver that calculates how close we are to the maximum, and then we use that value in the location driver calculating the location of the surface. It is much easier to understand what is happening when you split things up like this, focusing on just one thing at a time. In the close to maximum driver, we focus on only calculating how close we are to the maximum. And in the location driver, we focus on only calculating the correct height for the surface. However, after we have already figured out each individual part, it is a good idea to try to combine them to make the most happen at the same time. When we have a driver creating a value, and then that value is used in another driver, we might get a delay since the driver might not get the correct value until the next update. The fewer steps like this we have, the less delays we get, and therefore less lag. Since the close to maximum property is actually only used in the location driver, there is no need to have it as a separate property. Instead, we can add it to that location driver directly. So, let's prepare for adding the close to maximum driver to the location driver. The close to maximum driver uses two variables, the liquid amount and the current angle, so make sure those two are available in the location driver. The current angle is missing, so add that. Now, to combine the two, we need to take the expression from the close to maximum driver and add it into the expression of the location driver. Start by copying the expression of the maximum. Now, where should we put this? The expression we have currently copied gives the exact same value as the close to maximum property, so we will simply replace the close part of the expression with it. Make sure you have selected just the close reference in the expression and paste, replacing it. And now it continues to work like before, except that it lags less. The expression becomes really long and hard to understand, but that is okay since it already works. Now we can delete both the close to maximum driver and property since it has done what we needed it to, help us figure out and isolate one part of the expression. Also remove the old variable in the location driver. Now it looks like the surface is done, but what happens if I rotate the glass much further? The surface bone just continues to move, exposing new water at the bottom. Not what we want. It should never move above the edge of the glass, so add a minimum zero function to everything so it can't get a value higher than that. And now the surface is working like we want. Great. Now when the surface of the liquid is behaving like it should and the hard part is done, I would like to add a last function, namely giving the user the ability to change the shape of the glass. The shape of the object won't actually change. Instead, we will have multiple objects we switch visibility between, giving the illusion that you can change what the object looks like. I would like the user to be able to choose between 3 different styles of glasses, so we need to add 2 more of them. This can easily be done by duplicating the glass we have. But before we do that, I would like to improve the glass a bit. Always do everything you can before you do any kind of duplication, so you won't have to do the same work for multiple objects down the line. The surface of the liquid is already working, so we don't need to see it as clearly anymore. Completely removing the glass in front of it is not necessary, so I will turn off the back face culling and also recalculate the normals so they point the way they should. Secondly, this glass shape is not ideal. I want to scale it up a bit further to make room for adding some thickness to the glass. Add a solidify modifier and set the thickness so it almost touches the water. And now it looks like a real container. However, since we just scaled everything up when we created the glass, the edge is a bit too high. It should have a height of exactly 2 for the liquid to match, so select the upper edge and set the median global height to 2. Also move the bottom face up so it is right by the liquid. Finally, apply the Solidify modifier and apply the scale of the glass. I would also like to fix the shading. Currently it doesn't look good at all since we can see the polygons of the glass very clearly. Let's start by switching to smooth shading. This doesn't look better, but we can easily fix it by adding an edge split modifier. And now the glass gets a smooth and nice surface. Even though we removed the back face culling, I would still like to be able to see the shape of the liquid. But this time I will do it using transparency. Add a new material to the glass and set the viewport alpha to just 0.2. We don't see any difference, and that is because transparency is not activated for the object. You do that in the object panel under display. And now it looks almost like a real glass here in the viewport. We have now fixed everything I wanted to fix with the glass, so now it is ready to be duplicated. Duplicate it, move the new copy to the second layer, and go there. For this second style, I want to add a simple ear to the glass. This is just to demonstrate how we can switch between different shapes in an object, so I will do this very roughly. When it is done, duplicate the original once more and move it to the third layer this time. This one I will turn into a kind of wine glass with a foot at the bottom. Now we have 3 different styles of glasses. To be able to switch between them only seeing one at a time, add another custom property to the armature and name it glass style. Give it a range from 1 to 3 with only whole numbers. That way we can only pick between 3 different styles, which is perfect since we have 3 different glasses. To only make one glass model show up at a time, we will use mask modifiers. At each of these values, 1, 2, 3, only one model will be shown and the other 2 will be hidden, creating an illusion that the object is changing shape. Let's start with the first glass, the original. Add a mask modifier to it and add a driver to the toggle. Add the glass style as a variable and set the expression to style equals 1. Now when the style is equal to 1, the expression becomes true and the mask is toggled. And if it is not 1, it becomes false and the object stays hidden. This way, the object will only be visible when the style is 1. Let's do the same thing for the other glasses. Copy the driver and move over to the second glass, the one with the ear. Give it a mask modifier as well and paste the driver to the toggle. We want this glass to only be visible when the style is 2, so change to a 2 in the expression. Go to the third and final glass, add a mask modifier, and paste the driver here as well. I want this one to only be visible when the style has a value of 3, so change the expression to 3. If I now select all layers so all glasses are included, I can easily switch between the 3 different styles by changing the style property. Since only one object will be shown at a time now, I can move the 2 new glasses back to the first layer. Great. Right now the user have the controls it needs. It can move the entire glass, refill and change the style. We could leave this as is, but I would like to take a different approach to control in this one compared to the other objects we have done so far. That is, instead of controlling things by changing values in the custom properties panel, I would like to create a floating panel. A floating panel puts these controls inside the 3D view, so the user can place and scale the controls as it likes. This will be achieved by adding several bones and giving them custom shapes so it all looks like a control panel, even though the user is actually just moving normal bones around. Let's start by modeling the panel itself, the object that will hold the different controls. Move the driver window out of the way for now by shrinking its size so we get some more space. And move to another layer so we can focus. I will start by creating the slider for the refill control, so add a plane and go to top view. These bone shapes will only be seen as wireframes, so I will switch to wireframe view so we can see what they will look like. Now, how big should this slider be? Well, the height doesn't really matter. It is only a question of looks since the control won't move up or down. I will give it a height of 0.13 since I found that looks good. The width on the other hand needs a bit more reasoning. It is always easier when we can keep things at whole units, so I would like for the refill slider to be exactly 1 unit long. That is, the control needs to be moved exactly 1 unit to go from one side to the other. However, the object you move, the actual control, will need a width as well, so we can't make the slider just 1 unit long. I will give the control a width of 0.2 units, so I want the slider to be 1.2 units wide, giving room for both the control and space for it to move. So give the plane a width of 1.2 units. Let's apply the scale now when we are happy with the shape. We now have the slider container, so let's create the object that will move inside of it. Add a new plane and change it to a shape of an arrow pointing to the right, indicating how the control only affects the object when it is moved to the right. I will model the arrow with the original width of the plane, 2 units, and then scale it down when I am done. It needs to have a final width of 0.2 units, so scale it 0.1. We want the arrow to start furthest to the left, so move it there, to a position of -0.5. Just to avoid intersection with the ends of the slider container, I will make it slightly shorter in edit mode. When you are happy with how it fits inside the slider, apply the scale. We now have the refill slider, so let's create one for the style as well. Duplicate the slider container and move it 0.3 units down. We want the actual sliding part to be exactly 1 unit wide for easy calculations here as well, so add 2 loop cuts at both ends, 0.1 units in, so the center part gets a width of exactly 1. We have 3 different styles of glasses, and it is this centerpiece that will hold these different choices. So we want to give it 3 different sections, so add 2 loop cuts. To make it clear where the switches between the different sections are, I would like to give them different heights. Add a loop cut along the length of the slider, pretty far down, and remove all extra edges so the shape becomes a single continuous loop. This gives us a clean and nice shape, showing clearly where the switches happen. Now we just need to add the object that is supposed to move inside the slider. Add a plane, move it down to the slider container, and scale it down. I want to give it the shape of an arrow pointing down so it is clear that it is the tip that decides what section is currently selected. When you are happy with the shape, move it to its start position at -0.5 and apply the scale. Now when we have the shape of the actual controls, we can improve the look of the panel itself. First add a new plane, encapsulating everything. Resize it so it fits nicely around the sliders with some room to spare. Apply the scale when you're happy with the shape, and then join the 2 slider containers to it, collecting it all in one object. We also want to add some text describing what each slider does, so add a text and set it to center alignment. change it to say refill, and place it above the refill slider. Duplicate the text and place it above the style slider. Change the text to glass style and shrink it down a bit so it doesn't look so big compared to the refill text. We would like these texts to be part of the same object as the rest of the panel, but to be able to do that, we need to convert them to meshes first. Convert from text to mesh and then join them to the panel. We get some nasty lines in the text showing every polygon, but just enter edit mode and leave again to make them disappear. Now we have a panel, the refill control and the style control, so let's rename the objects accordingly. Panel, refill control, and style control. With the meshes done, it is time to use them as shapes in our armature, so jump back to the first layer. We will need 3 new bones, one for each object. Place the 3D cursor to the side and add the first bone, the panel. Add 2 more bones, the refill control and the style control, placing them a bit apart. Now, to turn these bones into something that actually looks like a panel, we just need to give them the appropriate custom bone shapes. Panel, refill control, and style control. And now we have what looks like a floating panel. Since the controls should stay with the panel when I move it around, I need to parent the control bones to the panel bone. And now everything can be moved around by moving the panel. Currently, the 2 controls are not appearing where they should, inside the sliders. We could try to move the bones around in edit mode to compensate for their offset, but I will modify the meshes instead. First of all, I want to give all 3 objects the same origin point. That way, the floating panel will continue to look like this as long as they all have the exact same coordinates. So move the cursor to the panel mesh and set the origin to the 3D cursor for our 2 controls. Now to make the controls appear in the correct location in the armature, all we need to do is to place the 3 bones in the same location in edit mode. We could change their thickness to make them stand out from each other, making it easier to see that there are indeed 3 bones there instead of 1. But I don't bother with that, since these bones won't be touched anymore. And now the panel looks just like the mesh we created earlier. With the look done, it is time to limit how much we can move the actual controls. Currently, they can be moved too freely. Let's start with the refill control. We only wanted to be able to move along the slider, so add a limit location constraint. Set it to local space since we want to limit it within its parent, the panel, and also activate for transform. It should be able to move between 0 and 1 along X, so activate those and set the maximum to 1. However, it should not be able to move in either Y or Z, so lock those completely, keeping them at 0. And now the arrow can only be moved inside the slider. Add the same constraint to the style control by copying. And now it remains inside its slider as well. Great. Now we have the controls in the viewport behaving like we want, so now it is just a matter of making them actually affect the object. Let's start with the refill control. The easiest way to do it is to just drive the refill property based on the location of the control. So add a driver to the refill property and expand the driver window again. Add the refill bone as a variable, X location local space. With this refill control, I would like to make the refilling work a bit differently than it has done in the past. I want the slider to directly reflect how much you fill. If you move it to the middle and then move it back, I want half of the glass to get filled. And if half of the glass is already filled, I want nothing to happen until the control reaches halfway. To do this, we need to check if the control position is bigger than the current amount of liquid. So add the liquid amount as a variable. The glass should only be refilled if the control has a bigger value than the current amount, so I will add an if statement that checks just that. If refill is bigger than amount. If it isn't, I don't want anything to happen, so I will write else 0. However, if it is, we want to add the difference, how much the control is bigger than the current amount. For example, if the control has a value of 0.6 and the current amount is 0.5, we want to add 0.1 so the amount gets the same value as the control. So write refill minus amount, the difference between the two. And now the liquid is only increased if I move the slider further than the current amount. The refill is working, so now I can think about optimizing it. Since the refill property is only used in a single driver, it is pretty unnecessary to have a separate property for it. All it does is introducing extra lag, making the change in surface become delayed, since we are saving a value we use in an intermediate step. Figuring out the refill expression was easier when we had it in a separate driver, but now when it is already working, we can try to combine the two, just like we did with the close to maximum driver earlier. First copy the expression from the refill driver, and then go to the liquid amount driver. We need to replace this refill reference with our copied expression. So delete it, add 2 brackets so we clearly collect our refill expression in one place, and paste. The entire expression becomes long and hard to understand, but that is okay since we already know that it works. The expression we have now still references a variable called refill, which we already have in this driver. However, it needs to be the same variable as we had in the refill driver, not just share the same name. So change it from pointing to the refill property to the local X location of the refill bone. And now it works like before, only with less lag. Since the refill property is not used anymore, we can delete both the driver and the property. With the refill control done, we can move on to the glass style. Add a driver to the glass style property and add the style control as a variable. X location, local space. The style control can have a value between 0 and 1, making it switch at 1/3 and 2/3. However, the glass style property changes styles at whole numbers, so we need to multiply the style by 3. Also, the glass style property starts at 1 instead of 0, so we need to add 1. Now we get a correct output, changing the style of the glass at 1/3 and 2/3 along the slider. However, when we reach the end, all glasses disappear. This is because the driver gets a value of 4, and the visibility of our glasses are triggered by values from 1 to 3. We can make sure the driver never gets a value higher than 3 by adding a min function 3 to it. And now the style selection works perfectly. Since this glass style property is actually referenced in 3 different places, once for each glass, I am not going to try to get rid of this property by combining drivers like I did with the refill property. If I did, I would have to create basically 3 different copies of the same expression, adding it to all 3 mask drivers. And in this case, keeping the property separate is not a bad thing. It is used in multiple places, and the usability of the style selection doesn't suffer from the lag. So I will keep this glass style property as it is. And now the floating panel is fully functioning. Great. Now the basic functionality of the glass is complete, so all that is left to do is to add some finishing touches. We won't need to change any more drivers, so we can close the driver window. Let's start by fixing the shading of the liquid. We will give it the same treatment as we gave the glass. Set the shading to smooth and add an edge split modifier, giving it a nice surface. As you might notice, the surface of the liquid is not behaving perfectly when we move it around here in the viewport. But what does it look like when it is animated? Let's take a look. Add 3 keyframes to the glass bone so it rocks back and forth. And change the frame range so it loops. When we now play the animation, the surface kind of jumps around and it doesn't look nearly as nice as it did when I demonstrated the glass in the beginning. This is because it is not updating properly. We can fix this by forcing Blender to do an extra update every time we move on to a new frame. With the armature selected, go to the Object Data panel and under Relations Extras, activate Extra Data Update. Now when we play the animation, you can see how the liquid and surface pool doesn't follow the surface bone anymore. They just glide around, not sticking to it like they should. This is because the armature is now updated correctly, but the liquid and surface pool are not. So select those two and activate Extra Data Update for them as well. And now the surface behaves like it should, not jumping around. Great. Unfortunately, you can't force extra updates for when you move things around in the viewport, only when changing frames, so the glass will stay a bit laggy when you pose it. However, you don't really need to see the liquid in perfect smooth motion to be able to pose the glass, so I don't see it as a usability problem. We can remove the keyframes and reset the range since we have finished testing the animation. Now we want to hide some things that should not be seen. First of all, the user should not touch any other bones other than the master and the panel, so move the rest to another bone layer. Also, we want to adjust the visibility of the surface pool. Hide its visibility both here in the viewport and in renders. It will still be able to change the shape of the liquid. To make the floating panel look a bit better, you can turn off relationship lines under display so you don't have to see those dotted lines. To clean up even more, we can actually delete the meshes we used for the custom bone shapes. They will be saved anyway as long as the shapes are used in a bone. And to avoid accidental changes, turn off viewport selection for everything except the armature. Also lock the rotation and scale for the panel controls and the rotation for the armature itself. And that's it. This concludes the tutorial on creating an automatic glass of water. I hope you have learned something. Thanks for watching.